Hi there, here is Luque Gariboni, the Extension Soil Fertility Specialist at Crop and Soil Science Department, NC State University. In this presentation, we'll talk about how to identify sites impacted by saltwater intrusion. First of all, let's talk very quickly about the origin of salts in soils. Salt water from ocean can invade the coastal soils, especially during the storm surges associated with hurricanes. Or we also can have salts coming from the groundwater and going to this region, these soils, accumulating salts. And the accumulation of salts is because salts are attracted to the soil particles. And so the water evaporates, or we can drain the excess of water, but the salts will keep in the soil. And so we are always accumulating salts after we have this salt water invading the soils. And the accumulation of the salts occurs because our soil particles, we have in these particles these negative charges. And the negative charges are the CEC, the cation exchange capacity of our soil. And these negative charges are used to hold nutrients, for example, calcium, magnesium, potassium, and all these nutrients are useful for plants, and the CEC is the property of your soil that will hold these elements. And also we have some other elements that are not interesting for plants. They are toxic, like aluminum and hydrogen, and the CEC will hold these elements because as the soil has these negative charges, the nutrients or the elements with positive charges like calcium, magnesium, potassium, and also sodium, all of them will have positive charges, and so they will be attracted by the soil particle because the soil particle has negative charge. And so when you have salt water coming to the soil, we have this sodium invading the soil system. And after that, we can have the evaporation of water, we can have the water uptake by plants, and we also have the drainage of the excess of water. But as the soil will attract the sodium will keep in the soil system, while the water will go out from the system because the evaporation, water uptake, or drainage. And so when we think about the how the sodium accumulates in these coastal areas, is just because we have this accumulation, this process, the sodium with water coming to the soil, the water will evaporate, or we have the plant uptake, or we have the drainage, and the sodium will keep in the system. And if you think about another event, another saltwater intrusion, more sodium will come to the soil and will accumulate it. And more sodium in the next event will accumulate. And over the years, you are accumulating sodium in these soils. And what are the problems related to the sodium accumulation? We have a soil particle dispersion, and so we'll destroy the soil aggregation, and we'll have the soil as a powder, very small particles. And because we have the soil, this degradation of the aggregates, the soil will have surface sealing, and it will affect the drainage of the soil. And you can see in the surface in this picture that we have this surface sealing. When you think about the problems with sodium for plants, when you start to imagine that this is inside the root and this is the water in the soil. When you have too much salt is going inside the plant, we can have salt toxicity. And if you have a lot of sodium outside in the water, this sodium will hold water. Remember that sodium or salts in general, they like to keep water around these particles, and so if you have too much sodium in the water, the plant cannot take up water. And it's interesting because it's a situation where we have water in the soil, but as this water we have a lot of salts in this water, the plant cannot take up the water. Okay, and now let's see how to evaluate if our soil is affected by salts. When you send a soil sample to any CDA soil testing lab, you have this type of report. This is a soil report, and you have all the characteristics of the soil, humic matter, CEC, base saturation, acidity, pH, phosphorus, potassium, calcium, magnesium, sulfur, manganese, zinc, and copper. All these information are important to look at the soil fertility of your field. But we have two specific information that are very important regarding salts. The first one is sodium, and you can see here. And the second one is the exchangeable sodium percent. That is the second number. These two information will tell you about the amount of salts that you have in the soil. However, if you know that you have a problem in your soil, you can send your soil sample to any CDA and request a special analysis. When you think you have a problem, you can ask for a diagnostic analysis, and any CDA will perform these two analyses, sodium and exchangeable sodium percent, and also they will give you a third important information, soluble salt index. And so when you ask to any CDA for a diagnostic soil analysis, they will send you 3 pieces of information that are very important to understand if your soil is impacted by salts. These 3 pieces of information are sodium, exchangeable sodium percent, and soluble salt index. Remember, the common soil test report will give you 2 pieces of information, and the special soil test report, if you request, will give you 3 pieces of information to look at the salt problems in your soil. Now I will show you 3 different soil test reports. I just cropped the important information of these 3 soil test reports. And remember, we have sodium and exchangeable sodium percent in these common soil test reports. And look at this interesting thing. Look at these 3 different soil test reports, 1, 2, and 3. And you can see that all 3 reports have the same amount of sodium. And my question for you is, if I have the same amount of sodium, do I have the same problem with salts in these 3 different fields? Now let's look at the second piece of information, the exchangeable sodium percent. And so exchangeable sodium percent, you can see in these 3 different samples that we have different percentages. The first one is 6%, the second one is 8%, and the third one is 16%. What is this number? This number is the percentage of sodium that you have in your CEC. And look at the information here. The first sample, we have a higher CEC, 7.1. It means that I have 0.4 of sodium in 7.1. In the second field, I still have the same amount of sodium, but my CEC is lower. It means that I have the same 0.4, but these 0.4 are in a soil with a lower CEC, 5.2. It means that the percentage of sodium in this CEC will be higher. And in the last sample, the sample number 3, we still have 0.4 of sodium, but my CEC is very small, 2.5, and 0.4 of sodium in 2.5 of CEC represents 16%. It means that 16% of all soil charges are with sodium. And here is the way that the exchangeable sodium percent is calculated. It is 0.4, the amount of sodium divided by the CEC. The amount of sodium divided by CEC. Again, amount of sodium divided by CEC. And so you can see that the exchangeable sodium percent will be different in these soils. Is this important? Yes, it's very important. Look at this example here. We have here a soil particle, and we have a high CEC in this example. It means that we have a lot of negative charge in this soil. And if you have a lot of negative charge, you can hold a lot of elements around the particles, okay? And imagine that we have some of these elements that are sodium. When you think about a plant here, and this plant is taking up nutrients from this soil, you can imagine that we have nutrients, the green ones here, and you have some sodium. Sometimes the plant can take up sodium, okay? But imagine the same situation in a low CEC soil. We have the same amount of sodium in the low CEC soil, and you have your plant here taking up the nutrients. But now, because we have less nutrients in this soil, because it's a low CEC soil, it's more likely to have this sodium taken up by plants. It means that the percentage is very important. We have the total amount of sodium. It's an important information, but more important is the percentage of that this sodium is occupying of the CEC. It means that if I have a high CEC, I have less problems with sodium. If I have a low CEC soil, I have more problems with sodium. How to look at these numbers about the exchangeable sodium percent? Exchangeable sodium percent is a percentage of the CEC, and how NCDA classify this number. The NCDA tell us that if I have ESP from 0 to 10%, plants are not affected because it's a small percentage of the CEC occupied by sodium. If you have from 11 to 15, plants may be affected because you are increasing, you have a little bit more sodium in the CEC. From 16 to 20, plants are likely affected because you have enough sodium in the soil to affect the plant. And if you have more than 20%, plants will be for sure affected by salts. And so we have this threshold that the NCDA recommends. If you have less than 15, probably you are in a good shape. But if you have more than 15% of the ESP, probably we have too much sodium, and probably we will have problems to grow crops in this soil. Okay, so we have another problem. When you have a soil with high ESP, we start to have other salts. Here are the sodium, but if you have a lot of sodium in your system, other salts like sulfate, like chloride, like potassium, even potassium, can start to harm the plant because the sum of all salts in the system will affect badly the plant. And so when we have high ESP, higher than 15%, we need to look to other things, not only sodium, but also to other salts that can affect. It means that the sum of all different salts will be important in soils with ESP higher than 15%. Okay, and so when we have these soils with high ESP, the total soluble salts should be investigated by using a diagnostic soil testing. It means that if you send a sample to NCDA and the results showed you more than 15% of ESP, you should call NCDA and ask them to run that sample again as a diagnostic soil testing, a diagnostic soil sample. When they run this sample again, they will do this special analysis, soluble salt index. And the soluble salt index is the sum of sodium and other salts that can affect the plant. And we'll have, in this situation, we'll have in a diagnostic soil report, we'll have three information. We'll have sodium, we'll have ESP, and we will have soluble salt index. And the soluble salt index, we have another classification for the soluble salt index. If you have 0 to 50, plants are not affected. If you have an index from 50 to 100, plants may be affected. And if you have from 100 to 150, plants likely will be affected. And of course, if you have index higher than 150, plants for sure will be affected. And again, we have the threshold, and the threshold, the limit that any CDA considers as a problem is 100. If I have more than 100, I have problems with salts. If I have less than 100, probably we don't have problems with salts. Now, let's integrate the two different types of information. Remember, all soil samples, you can have the exchangeable sodium percent, the ESP. It's standard for all soil test reports. And if you have a diagnostic sample, you also have the soluble salt index. When you have these two pieces of information, you can use this graph to make a better interpretation of your soil. And let's use some examples to see how we can classify different soil samples using this information. And again, you can see here areas of this graph where we don't have problems for plants. We have another area that maybe you have a problem for plants. Plants will be likely affected in this region, and for sure plants will be affected in the red region of this graph. Let me change the color of my, okay, now I can see. Let's use some examples. Look at this example. We have two different fields. In the first field, the soybean is healthy, and in the second part of the field, the soil is not in a good shape. And in this first field, they got soil samples from two depths, 0 to 6 inches and 6 to 12 inches. The same thing was done in the second one, 0 to 6 inches and 6 to 12 inches. And let's see the results. This was a salt-affected soil after the Hurricane Florence in Hyde County in 2018. Look at these soil samples, 0 to 6 inches in a healthy area. The ESP was 7, and the soluble salt index was 48. And you can see here 7 and 48. And this sample was here. It means that probably the plants were not affected, and you can see that we have health plants in this sample. Let's see the second layer of the soil, 6 to 12 inches depth. The ESP was 8, and the soluble salts were 25. And again, we are in a part of our graph that we don't have problems and plants were not affected. And so for the two samples here, we can see that this graph showed very well that we have soils in a level of salts that we don't have problems. Okay, let's see the affected area. The first sample, 0 to 6 inches. The ESP was 14, and the soluble salt index were 120. And you can see that we are in an area of this graph that plants are likely affected. And you can see here that the soybean was affected by salts. Okay, let's see in the second layer, 6 to 12 inches depth. Again, 14 exchangeable sodium percent and 53 as the soluble salt index. Again, plants might be affected. And you can see using this graph, it's very easy to see that the first sample, the 2 layers of the soil were in with an amount of salts that are okay for plants, and in the affected area, the 2 layers were with excessive salts, and you can see problems with plants. And so with this graph, it's very easy to compare and to identify soils with problems. Okay, let me show you some other examples. And here we have an example from Perquimans County, and we can see that samples from a good part of the field and from a bad part of the field were sent to the NCDA, and you can see in the good area, the sodium was 0.1. In the bad area, the sodium was 2.0. The ESP was 2% in the first area and 25% in the second area. Because it's likely to be problems with salts, the extension agent that was in charge of these fields, he asked to NCDA to run the samples again as diagnostic samples. And the results showed that in the first area, when they run as an diagnostic sample, the first area, the soluble salts were 6%, and in the second area, the soluble salts were 128. And so look at the difference between the first area, the good area, the sample was located here in the graph, no problem for plants, and in the second area, in the bad area, the sample were in a region of the graph where problems are likely to occur or surely will occur. And so again, the graphic is very easy to separate the areas without problems and areas where you can have problems with salts. Here we have another sample. Again, we have good area and bad area. And you can see that the sample were run as diagnostic sample, and so you have the results for sodium, ESP, and index, and you can see the numbers. We have the 3 pieces of information here, and the good area, low sodium, and the bad area, we didn't have too much sodium in the bad area. You can see 0.1, 0.3, not too much. The percentage, 2% in the first one, 4% of sodium in the CEC in the second one. Again, is not too bad. But when you look at the soluble salt index, you can see that, especially in the second one, we have this huge soluble salt number. When you put this information here, you can see that the first sample we are in a good area of our graph, and when you put this information here, you can see that likely we have problems with salts. And the bad area, this is a photo of the bad area, and you can see the accumulation of salts in the soil surface. Sometimes you can see these salts accumulating in the surface after the evaporation of water. Some other examples. This is Hyde County, and sample number 1, ESP 16%, soluble salts 97, and the sample is here, and plants likely will be affected. Another example, ESP26 and soluble salt index 150. We are here, and this area we sure have problems with salts. Third example, we are here, problems with salts. Fourth example, again, problems with salts. Fifth example, again, problems with salts. Sample number 6, still have problems, but we are in a area of your graph that maybe we cannot have problems, and so it will depend on the drainage of your area and how your plants can handle these salts. But let me show you the last sample of this example. In the last sample of this example, the ESP is 36, and the index is 373. And my graph are going only to 200. It means that I'm out of the chart, and this sample is away far from here, much far from this graph. And so when I reshape my graph and I have 200, 300, 400, we can see that number 7 is here. Healthy plants without problems with salts are only in this green part, and I'm away far from this. It means that this sample, it's a very problematic site with a lot of salts accumulated. Let's see some of the other examples. Cataract County. Sample number 1, probably have problems. Number 2, the same thing, ESP 18, index 70. We are in a region of our graph that likely problems will be occurring for plants. Number 3, maybe, depending on the year, we don't have too much problems with this sample because you are exactly in the threshold, the ESP 15, and the soluble salts 6.2. Maybe we still can grow without problems our plants here. Sample number 4, and maybe we can have some problems, but probably not. Sample number 5. Sample number 5. You are up here, and this sample, this field, for sure we have problems. And sample number 6, we are out of the chart, salt problems for sure. And sample number 7, again, it's away far from this graph, and I rescale my graph, and the sample number 7 is here. Here is the region without problems, and my sample number 7 is here. It means that this field, for sure, a lot of problems with salts will occur. And some more examples. I think this is an extreme example, Hyde County. And sample number 1, we have problems because we have a ESP 24, and we have soluble salt 100, and so I'm in the red zone, and here we have problems. Sample number 2, for sure, with problems, we have ESP 28, and we have soluble salts 224. And sample number 3, look at this number. DSP is 89%, and my graph is going up to 40. and the index is 807. My graph is going only up to 200, and these numbers are unbelievable numbers of sodium. And in this sample, we can imagine 89% of the CC, remember the soil charts, 89% of the soil charts are occupied only by sodium. It's impossible to grow plants in this sample because no, we don't have plants that can hold this amount of sodium. And probably this will be an abandoned area, and we'll have marsh in this area because of the excessive salts. Okay, and so the final remarks about this presentation, how to look at the soil test reports and decide or identify areas with possible problems of salts. Let's just go back to the key points. The first one, NCDA standard soil test report informs sodium and ESP, two pieces of information. Soils with ESP below 10 are considered not affected by salts. Soils with ESP higher than 15, this is our threshold for ESP, are considered affected by salts. If you have a soil with ESP higher than 15, it's recommended to request a diagnostic soil test analysis. This diagnostic soil test analysis will be very important because this diagnostic soil test analysis will inform you the soluble salt index. And the soluble salt index will be another important piece of information to classify your soil as a site with problems or without problems with salts. When the soluble salt index is higher than 100, it indicates that we have salt problems in your soil. And again, the thresholds, this is very important. ESP higher than 15%, probably have problems with salts. And if you see your soil test report, your standard soil test report with a ESP higher than 15%, request to NCDA a diagnostic soil test analysis, because this diagnostic soil test analysis will inform you about the soluble salt index. And if you have a soluble salt index higher than 100, you have problems with salts. This is your diagnostic. Okay. If you want to send diagnostic samples to NCDA to identify if you have problems, you can ask for your extension agents of your region to send the sample for you, and you have more information about this, how to collect and how to send these samples, assessing the soil fertility portal at NC State. soilfertility.ces.ncsu.edu. And so if you have any question, please reach out to me. Thank you for watching this presentation. Have a great day.